Okay, what I want to do now is go over the format of the midterm. Okay, the format before we begin the last section of review. And I'm going to quickly do this. So either write this down real quick, okay, or watch the video later so you can get it down. But I'm going very quick now through the overview. First, I want everyone's attention. Let's go. I'm telling you guys now, I've been sick the last 2 days. If I'm not there tomorrow morning, there's a good chance I won't be in school tomorrow. I'm telling you right now. I probably was going to come in today, but I couldn't leave you guys without review. That's why I'm here. But I'm just telling you this just as a forewarning, so tomorrow there's no questions about format. Okay, the test is very straightforward. Okay, it's the same exact setup as all your tests have been all year. There are going to be 3 parts to the exam: multiple choice, short answer, and free response. There are 30 multiple choice problems. Okay, this is the only time I'm going to use a Scantron the entire year. So you're going to have a Scantron with 30 multiple choice. So part 1 goes on the Scantron.
Other 1.5.
Parts 2 and 3, okay, parts 2 and 3 are going to go on an answer booklet that I've already made up for you. It's not a blue book, and I'll show you the answer booklet after this so you can see what it looks like. So you have part 1 is in the Scantron, parts 2 and 3 will be on an answer booklet. The actual test itself you can write on, but it will not be graded, and you'll see the answer booklet. Okay, you'll also be provided, I'll take questions at the end, hold on one sec, Jack. You'll also be provided with the formula sheet, the one that's on Moodle under documents and handouts. It will look identical to what it is. For part 3, or the free response section, you will be given 8 problems. You only have to do 5. So for 3 of them, you're going to write the word omit. Okay, so you choose 5 of 8 for the last section. So the last section again, and I'm looking right here. Okay, the last section, there are 5 questions worth 8 points each. But there are going to be 8 on the exam, and it will clearly say, choose 5 of the following questions. The 3 that you do not want to be graded, write the word omit on. Is that clear? Yeah. Okay, if you don't write the word omit, I am grading the first 5, even if you leave them blank. You need to write the word omit. Make sure you follow directions. So you're going to answer 5 of 8 in the last section. Everything else, you're doing all 30 here. You're doing all 30 multiple choice, and you're doing all 10 short answer. Same setup as your exams have been, no different whatsoever. Jack, your question.
What's the difference between short answer and free response?
Free response will be mathematical, short answer will be conceptual.
Got it.
Okay? As stated in your announcements this morning, make sure your calculator's memories are clear. Okay, your proctor's coming around to check your memories on your calculators. Please clear them out. Please, if you have trouble clearing them out, come after school today. I have office hours. I will show you how to clear them out, or ask any math teacher.
If there's just like 6 times 7 on it, equals,
that's not
Then you just clear it out, and it doesn't matter. No, you're not supposed to have it on there because Ms. Stark said you're supposed to have that memorized for her class anyway.
No, she said you can use it for the. Ms. Stark said yesterday that we can.
Talk to her. Talk to her. I'm just telling you, okay? Just so you know, your proctors are going to come around and check. And this is not just science, okay? Science and math, obviously. Also, some of you have been borrowing calculus from each other. That's not going to be possible because everyone is going to be taking the exam at the same time. So for some reason, they are as well. Everyone in the whole school is taking math and science on the same time. Thursday is science, Tuesday is math. Make sure you have a calculator. Do not come to the math science office asking to borrow. We will not give one because it's not fair. Okay? If 30 people come by, there's only 4 teachers or 5 teachers in there. It is not fair to us to lend 4 of them out and then the other 26 are left without it. You need to have one. You need to have one. If that means borrowing from your older brother or younger sister or younger brother or older sister or parents or whomever, do so. Okay, but make sure your calculator memory is cleared and that the batteries are working. Miss Arusi has batteries. She's selling them very cheap. I don't know how she's managing that, but only 50 cents a battery. Okay, so make sure you come ask her, not on the day of the test, but ahead of time. That means today, if you're getting it for tomorrow's test, or that means tomorrow or Friday, if you're getting it for Tuesday's test. Let's go look at the answer booklet. The answer booklet will look like the following. Notice numbers 1 through 30 are not here. Where are they? On the
sheet.
Scantron, multiple choice, okay? So, short answer starts with number 31. And you'll see that I put little score boxes up here. You're going to leave those blank, obviously. That's for me to keep your score. So short answer, 3 points each. And you'll see, watch what I'll do. Stop talking, guys. You'll see that for problems that are just normal, there's no ABC. Okay? They're just those. Then for here, for number 41 and 42, you'll see at the top it says, choose 5 of the next 8 questions. Write omit on the 3 problems you wish to exclude. Please make sure you do so. Okay? So you see 40, 42, 43 and 44, 45 and 46, 47 and 48. Okay, so that's what the answer booklet looks like. So all your answers are on a Scantron and the answer booklet. Now, your test will be given to you all as one packet, and it will be paper clipped. You'll see a Scantron, the test itself, the answer booklet, and the formula sheet. All 4 of those need to be then paper clipped at the end and turned into the proctor. Put your name on everything. But make sure you paperclip it together. If for some crazy reason, say you forget to put your name on the Scantron, if it's paperclipped with your test, I know it's your Scantron. Okay? Again, name on everything. Put them all together with the paperclip that you receive, okay, that you got with your test.
Is this going to be like in directions or something tomorrow? I'm going to forget.
All the directions will be written on the test, okay? And your proctor has directions that he or she will read aloud to you as well. Okay, just think about it this way. The way you get your test is the way you turn it in. Okay? The same way you get your test in one packet is the way you turn it in. If you have extended time, you know you need to be at your test at the latest by 8:30. Okay? That's when it actually starts. Get there at 8:15. If you don't have extended time, your test starts at 9. Get there at 8:45 still. Okay? Please be early to your test so your proctor can seat you accordingly. You guys know this by now. You're in a room with other students from other classes. You will be sorted in a certain manner. Do not argue with your proctor about your seating. You're going to be sorted next to another student from another section on purpose. Okay? So you might be next to somebody from biology. Your proctor will not answer questions on the test. They will not. Okay? The Miss Myers will come around. I will come around. I think I'll be here tomorrow. But if I'm really feeling really poorly, then I may not. I'm just telling you now. I think I'll feel better. I hope so. I got a lot of sleep last night, but it didn't seem to help me much. Okay? So, again, the format is identical. Study your tests. If you're doing any studying tonight, review your tests. Until this point, you should have at least studied your problem sets, your tests, and your labs, and like maybe your notes. But if there's anything that you're going to study tonight, study your old tests. Okay? If you want to come by office hours today, come by, please. Again, today is 2:30 to 3:30. We get out at 2:20 today. It's a B day. Come by at 2:30 until 3:30 if you have any questions. Yeah, we're still recording right now. Let's start.
Where are you lost?
Fernando, go ahead.
Before we get into like the Q loss or whatever else, can we just go over like how to set up? Like I don't care about how to solve it. Just setting up.
Guys, come on.
Just setting up a question of like angle, like one of your forced angles.
So something with like the work done by a force exerted at an angle?
Like when you're pulling pulling a sled, can you just go around and set that up?
Yeah, we did that yesterday though, but we can go over it again. We did angle stuff yesterday.
Yeah, but now there's work done.
Okay, so let's do one with work done pulling on a sled. Okay, you're right. We did inclined plane and projectile. So let's do work done. And this will cover work as well. All right, here's the problem. If a force of 100 newtons is applied to an object at an angle of 60 degrees, if a force of 100 newtons is applied to an object at an angle of 60 degrees, over a distance of 8 meters, then determine the amount of work done. 8 meters. Determine the amount of work done on the object. God bless you.
God bless you.
Okay. Now, for this kind of a problem, we need to remember that all that matters is the force being applied in the direction of motion. So let's draw ourselves a little diagram here. Let's say that the object is moving to the right. We'll go from center to center, so from here. Okay, to here. So the object is moving a distance of 8 meters. There's a force applied at an angle of 60 degrees. Okay, that's what's going on for this kind of a problem. Now, for force, we can remember our formula, or we can look at our formula sheet. For work, sorry, thank you, Max. For work, we have force times cosine theta times the absolute value of x. Now, this seems tricky because there's no x, right? You don't see an x here.
Yeah.
But remember,
What you do, wouldn't it be d?
good. And if you remember, x is displacement, and the absolute value of displacement is distance. So this d is the same thing as absolute value of x here. Okay?
With the object values, I mean, does that really change anything?
No, but if the object were moved to the left 8 meters, you would normally say negative 8 for displacement, but it's just going to be 8. Exactly. Exactly. Stash.
So how do we know whether it's being pushed down to the horizon or up to the horizon? This equation.
It turns out for this one it doesn't matter, but it would say above the horizontal. For this it does not matter. If it's below, the cosine of negative 60 is still the same value actually. Think back to trig. Okay? I know you took it at your S.
I was thinking 90 minus 60.
Okay. But yeah, for this one it's still just going to be 60 either way.
It only makes a difference if you need friction.
If it said friction, you need to know that the cosine is 180 minus that value. Yeah, that's where you get that negative value. Yep. All right, so for a problem like this, okay, again, our angle is 60, our force is 100, and our distance is 8. Okay, so we can just plug in here. I know the heater's going crazy. Okay? The cosine of 60 happens to be 1/2. Okay, cosine of 60 is 0.5. And you can type that in your calculator and determine it. Make sure your calculator is in what mode? Degree mode. Degree mode. Okay, when you type in cosine 60, if you don't get 1/2, you should check your mode. It means you're in the wrong mode. Jeff.
What about the factor of cosine that we're trying to find out?
The answer is 400 watts.
Like when friction's going against each other, or it's like
180 minus whatever the angle is. So it'd be 120.
Cosine 60 is supposed to be
0.5.
But that's if there's friction going the opposite, right?
Correct.
And then
Exactly.
if it's going the
Oh, man, that
same
would've
zero,
really
It can't go.
that's-
Friction can't go the same way. Friction always acts opposite motion.
Yeah, but not. But let's remember, it's if it's going the same.
Oh, yeah, yeah. If the force is applied horizontally and is moving horizontally, theta is 0. Correct. Very
That
good.
equals 35.
Yes, and cosine of 0 is 1.
If there were frictions, would you just do it,
I'm going to do that. Give me a sec. I'll introduce that, yep? All right, now, you're going to get 400 joules, not watts. Be careful. 400 joules is your answer. Now, I want to go into the next part of this problem and think about this now. Imagine the force of friction also existed. So we're going to think about like maybe this problem would have like a part B to it. Now, it's the same problem, but friction acts against the motion with a force of 30 newtons. Okay? With a force of 30 newtons. And we want to now determine the overall work done. Okay? And we have to think about the fact that friction is what kind of work? What kind of work would friction be? Good. Negative. Negative work. Okay? Negative work. Now, what we're going to see is this. If we want to calculate the work done by friction, we have to look at our angle. And if we look, our motion, and I'm going to draw it with a blue line, our motion is this way. Our friction vector is to the left. So we think about the fact that the angle is how many degrees here? 180. And that's what makes friction negative. Because for the work done by friction, it's going to be 30 newtons times the cosine of 180 times the 8 meters still. And the cosine of 180 is negative 1. That's why the work done by friction happens to be negative here. So we're going to have 30 times negative 1 times 8, or negative 240 joules. So what is the overall work done on the system? 400 plus negative 240. Okay? So we just get a 160 as the overall value here.
Whoa, whoa.
Yeah, I don't get how you got
Go ahead.
it would be 70 each. Oh, because you're finding the work done by.
I'm doing them separately, yes, exactly. Max, I'm doing them separately. Had you done them together in one step, you would have to find the Fx component of the one at the angle, and then subtract the force of friction from it. Okay? And I can show that method in a second, hold on. But I can show that way.
So when there's friction, it's
difference
always
between
cosine
400
of 180.
Correct. If the object is moving to the right, and friction is acting to the left, what's that angle? That's 180. Okay? Tom.
Even if
Why do you take cosine 180? What's the logic?
It's always, whenever you're looking at the work done by an object, you'd multiply the force times the cosine of the angle that's between the direction and the force. So the direction is right, the force is left, that angle is 180. It's like a windshield wiper. Okay, that's what I think about.
but even if the friction's going left, and even if the friction's going right, it's if they're opposite, it's only thing that matters, right?
Yeah, because then the object would be moving left. The friction can never go in the same direction as motion unless you talk about rolling friction, but we haven't even done that. Okay, and that was the topic with like tires pushing a car forward. Daniel. The 30 newtons? That was given, sorry. That was given for force of friction up here. Okay? Now, I want to look at this problem again, the same exact problem, but I want to do it by resolving forces. Okay, so let's look at the same problem. And this is going to answer probably your question about using force and breaking it into components. So let's look at this problem now from the end though. So we have friction acting left. We've got this force applied, which is 100 newtons. Correct? 100? Was it 100 last one? Theta is 60. And we know that we're moving 8 meters to the right. And I'll draw it from front to front this time.
Do we even care about the FG and the FM?
Say again?
Would we even care about the FG?
No, because there's no vertical motion here. Nope.
But isn't there no vertical motion in all those problems?
Yeah, but remember, work is only done along the direction of motion.
Oh.
So since the direction of motion is horizontal, the vertical forces don't matter. And that's what I'm going to show you with this F.
That's the difference between work and we're trying to find kinetic, right?
Yeah. Yep. When we're doing kinetic friction, those things do take into account. Okay, now, if we wanted to do this problem by finding the overall force in the x direction, instead of looking at it this way, and we did this in class, so if you look at your notes, this will be familiar. What I want to do is break this F of 100 newtons into its components of x and y. So please, on your diagram, draw this now. Draw a little dashed line here and call that Fx, and draw a dashed line here and call that Fy. Similar to what we did with the force of gravity on the inclined plane yesterday. Okay? Now, raising your hand, please tell me. We have x and we have y. Which one is cosine? Which one is sine? Olivier? Cosine is x. Good. So we could say that Fx here is just going to be that force of 100 times the cosine of theta. And this is a little bit different than the method we just used here. Okay? Then Fy is going to be that F that we have applied times the sine of theta. Now, I'm sorry?
Why is it that?
I got different answers.
I mean, don't you need, for force, don't you need to know mass?
Perhaps.
You're thinking of inclined planes. So we have the force in the y direction is F sine theta. The force in the x is F cosine theta. So what we can do to solve this problem, instead of solving it the same way as last time we did 400, and then we subtracted the 240, and we got 160 as the overall work net. If we want to find work net instead, we can do it by finding F net times cosine theta times absolute value of x. But F net, remember, is only the things that are acting in the x direction. So what we really have is this acting in the x direction and this acting in the x direction. And if I take this 100 times the cosine of 60, what does that become? What did I say earlier? What was the cosine of 60? Yeah, it's 1/2, so we get 50. So fx is just 50. So what this means is that the person is pulling to the right with a force of 50 newtons. Friction is acting against motion with a force of 30 newtons. So the overall force felt is just 20 newtons. Okay, again, the person is pulling to the right 50, friction is acting to the left 30, so the overall is 20. Remember for work that only the forces that act in the direction of motion matter. So see that Fy up here? This Fy has no effect on the problem. Just like, we're not even drawing it, but just like Fg has no effect on the problem. And Fn has no effect on the problem. Because those are acting vertically, and this object is moving horizontally. Jeff?
Is it possible, just thinking and seeing the Fy, isn't that a right angle? So if the right of fall, the other angle would have to be 30 degrees. So you just plug in F sine 30.
It's F sine 60 it's going to be. It's always the angle with the horizontal, Jeff. Always.
No, did you see what I'm saying?
I know, but you're never going to use 30 in this problem. You're never going to use 30 degrees in this problem.
19 and 30. I'm saying by default, 60 and 30 equal 90.
I get you, but I'm telling you that 30 degrees is not incorporated in this problem anywhere, so don't even think about that one. Okay? If you were to compose, or you were to find this Fy here, Jeff, you would use the F of 100 times sine of 60. It's always the angle between the horizontal and the vector itself right here. Okay? Now, look what you're going to get though. If you think about this now, watch what I'm going to draw in the upper left. I'll draw it in blue. What I did was this, really. We made the problem, we redid the problem and just did it like this now. That's what's really going on. We took this 50 over here and subtracted this 30 and made it look like the problem was just this. This is the exact equivalence of what we have here, of this 50 to the right and this 30 to the left. Just making it 20 to the right is the exact same thing. So now, if you think about this angle is only to the right, what is the angle now between the force here, good, and the direction of motion? Okay, the direction of motion is to the right, the force here is to the right. So what we would have is, if we think about this, this line here is horizontal, this is horizontal. Two horizontals lying on top of one another are just an angle of 0. So it would turn out that this would just be cosine of 0, which is just 1. Very good, Jeff. Times 8 meters.
Okay, so this is the resultant force?
Exactly. This is the resultant force. And what does this become? What's 20 times 8?
160.
And what was the answer we got last time?
160.
Same exact answer, different method. Okay? If you look in your notes for work, you'll see that we did a problem like this also in class.
A little bit more.
Okay, we did one of these problems in class as well. So please go ahead and take a look at that if you want to study for work.
Oh, and then since there's no angle in the x direction, that's how you get cosine of 0.
Exactly, because we found the resultant force of 20 newtons instead of looking at the F and the FF. Olivier,
So when you do the Fy sine,
it doesn't affect it, exactly.
yeah.
Because it's acting vertically and motion in this problem is horizontal. And we remember that work is only affected by things that are applied in the same direction as motion.
Okay. But if we have to put a sine, sine 60.
Correct.
Not 30.
Not 30. Theta is always the angle between the horizontal and the vector itself, which was 60 in this problem. Okay? All right. Now, yesterday we did inclined planes, we did projectiles, we did work. Now, we should go on to energy maybe. Okay? Somebody asked a question about Q loss. Did we touch on Q loss at all? Did I mention about MEI and MEF?
We're all pretty confused on what Q loss.
Barely? Okay, what you should know for your over what you should know for Q loss. Q loss will come up conceptually, not mathematically. So Q loss will be a short answer. Okay? So remember this. In a perfect world, energy is conserved. Okay? In a perfect world, energy is conserved. And what that means is that we could say the following, and this is going to lead us into energy in a second. Now, the 1/2 kx squareds look the same, but they're not, even though they look identical. These are if there's a spring involved in the beginning or the end of the problem. There is never really going to be a spring involved in the beginning and the end. Theoretically, there could, okay, but I'm telling you now, you're not going to have a problem with that. So there's only going to appear either in the beginning or the end of the problem. Okay, is that clear? Now, the other terms, this is if there's elevation in the beginning of the problem, that's your potential energy. This is if there's elevation at the end of the problem. That is your potential energy at the end. This is if there's motion in the beginning of the problem, kinetic energy. This is if there's motion at the end, kinetic energy. Now, this is again in a perfect world where energy is conserved. We know though that when an object moves, there is some sort of friction and there's energy lost. Where does that come into play? That's what Q loss is. And what that means is that your equation becomes the following. Correct. Okay? And remember, you lose energy. So say there's 100 joules of energy to start. Okay? And you lose energy to friction. That means at the end, maybe there's only 70 joules of energy. How much is Q loss then? 30. So it's going to be 30. Okay? Q loss would just be 30. Again, if you started the problem with 100 joules of energy and somehow you only had 70 at the end, what's missing is right here. That's that Q loss. So Q loss would be 30 in this problem. Okay, so you need to know conceptually what Q loss means. It's energy lost due to some form of friction. Whether that friction is contact friction, like sliding on a surface, or air resistance, like an object moving through the air, it doesn't matter. It's the idea that you're losing energy due to friction. Okay, that's what you need to know about Q loss. Let's look at an energy balance mathematical problem. Let's say an object is fired from a cliff of height 200 meters with an initial velocity of 50 meters per second. Determine the velocity of the particle or object when where are you having trouble with? 200 meters.
I thought 200 meters was zero.
Oh, it's not.
Good one, man.
From a height of zoo, yeah.
No, not really.
A, let's say when the object is at, or when its height is 30 meters,
That's a zoo.
or and when it is at ground level,
At the end?
or whatever ground level is. Whatever ground level is to you. That's part of the question, Molly. That's why I'm not answering, okay? So at ground level. So again, determine the velocity of the object when its height is 30 meters and also when it's at ground level. Two-part problem. Okay, two-part problem. Now, if this were a problem in your test, each problem might be worth 4 points, okay, for an 8-point problem. Or maybe the first part is worth 5. And if you get that, then the second part is pretty easy, so maybe that'll be worth 3. Okay? So, the way we perform these problems is 2 methods. First, you can use projectile motion. That would be very messy. The minute you see a problem where you have some sort of height and velocity, and all you're looking for is one of the other 2 components, try energy methods. They're a lot easier. Okay, so let's look at mechanical energy. So, let's draw a diagram and label on that diagram the types of energies that we have. Okay, so I'm going to scroll up here. So here's my diagram. Here's a cliff. Here's ground level at the bottom. The object is launched from the cliff. Do I care about the angle it's launched at? Does it tell me?
No.
So don't worry. It could be launched horizontally, vertically. It doesn't actually matter. And that's the kind of crazy part here. Okay, it makes no difference. You can prove that kinematically, actually. So let's say the object is launched like this. Okay, and that's the path. Initially, the height of the cliff is 200 meters. Okay, we want to know the velocity at 2 points in time, right here and right here. We want to know the velocity when the height is still 30 meters and then also at ground level. Okay, and also at ground level. So we're looking at those 2 dots that I drew. That's where we're trying to find the velocity. We can call that V1 and V2. It really doesn't matter. But one is part A and one is part B. In the beginning of the problem, somebody raising their hand, tell me the types of energy. Olivier. Potential and kinetic. Very good. Because the object was launched from a height with some initial velocity. Velocity implying kinetic, height implying potential.
At rest, even though we know that.
But it's always going to be, that would have to be dropped from rest, correct. If it were dropped from rest, there would be no kinetic energy. Next, at the first dot, meaning the dot at 30 meters, what types of energy do we have? Molly.
Potential and kinetic.
Good. We have potential final and kinetic final. And that's like for part A. Everybody agree for part A?
Yes.
For part B, though, we kind of restart the problem now, right? For part B, is there any height anymore? So everybody, what drops off?
Potential.
Potential drops off. So for part B, we will only have kinetic energy. Okay?
What's that K? What is that K? Yeah.
Does it matter that it's 30 meters, not like 60 meters?
It could be 60, the numbers will just change.
It doesn't
If you end
actually.
up putting exponential energy, it would just cancel off.
Wait, so how do we find energy Y?
You can put it there, but then y would be 0. Yeah. So I just drop it off. I think sometimes it's just easier just to ignore it when you see that. But that's definitely right. Yep. Next.
Yeah, is that KEF or K in the ground level? It's KEF. Right?
Ground level is KEF. And you see KEF twice, but these are 2 different problems in a sense. Okay? These are like 2 different problems. Let's do part A.
Hey, Mr. Child, did you see that?
Say again?
He called me a butthead.
Called you what?
A butthead?
A butthead? Please don't call him a butthead.
That's right. I didn't want to have to do that, but
I apologize for my rude.
So part A, again. Initially, we have potential and kinetic. At the end, we have potential and kinetic. We have to start filling in our variables now. Jeff, potential energy. What's our formula for potential? Very good. And kinetic? Good. Equals? So Jeff, what do you notice that makes this problem somewhat easy? Exactly, and you must. Everybody notice that? Is mass given in this problem?
No.
So you have to. If you don't do that, you're going to be stuck.
Couldn't you always cancel out the mass no matter what?
When can you not?
Oh no.
When there's a
Yeah.
spring, because there's no M. Very good.
But
That's a
like,
good question. I like that.
It's like not gonna change mass magically when it's falling, so it doesn't not matter.
But the spring in the formula is 1/2 kx squared.
Yeah, like when there's a spring involved.
When there's a spring involved, you'll be given the mass. Okay? You'll be given the mass. Okay? Guys, tomorrow again, don't stress, study well. Okay? Make sure you look at your old test tonight. Part B doesn't look much different. And I'll just write it down so if you're watching this video tonight. Okay? I know the last stuff was new. Make sure you study again your momentum and circular motion. You have your test. Correct. G is 9.81. Yes. Very good.
We're learning new grammar.
Yes.
For like my exam, it's probably gonna be like I have to answer most of the questions.